Hello, everybody. This is Professor Ken, and this is the instructional video for January 26th, Thursday. Once again, I'm sorry I can't be with you today, but I've had throat surgery and I have no voice, so I made this recording ahead of time. Today, we're going to learn about frequency distribution tables. It's really not that difficult, but you'll have everything that you need to know in the slides and in this video. So when you use the slideshows or the slide deck to reference materials, it's always best if you use the slide deck as a slideshow and click through, because I put lots of animations and transitions in there and it enhances the learning and makes it more fun and interesting. So I would appreciate if you would do that. Okay, so I'm going to share my screen and turn off my video. All right. So if we go to course materials and click on January 24th and 26th, today's January 26th, and here's the slides for today, which I need to update. All right, so let me go into my folder. This is on spring 23. Stats and slides. Slides for January 26th. Okay, those will be up before the end of today. All right, so I'm going to go to slideshow from the beginning. All right, so today is January 26th, and the learning objective for today is by the end of this class, you will be able to create a frequency distribution table, know the terminology that goes along with it, and be able to analyze it. All right, so this is a frequency distribution table. We see on the left side, we have a column of data, and on the right side, we have how many times any occurrence in that data range happens. So if we add up the frequency, 68, 70, we see that we sampled 78 people for their IQ score. And of those 78, 2 of them fell between an IQ of 50 and 69. 33 of them fell in an IQ range of 70 to 89, 35 from 90 to 109, 7 from 110 to 129, and just 1 from 130 to 149. So we're going to analyze the parts of this frequency distribution table. All right, this first column is called the class. And in this case, the class is IQ score ranges. The class width is the band length in each row of the class. So when we look from 50 to 69, we probably think that the class width is 19, but it's really not. It's 20 because we would have to count 50. So the way I like to, I have another slide on how to calculate the class width. The class midpoint is the average of the endpoints of each band. So what's the average of 50 and 69? Would be about 59 and a half. The average of 70 and 89 is 79 and a half. All right, so the class width in this case is, on this particular row, is 20, because you would include, if you count from 70 to 89, 70 is the first data point, 71 is the second, you'd have 20 of them. So again, I made a slide. All right, the class midpoint of this row is 99.5, because 90 plus 109 is 199, and half of 199 is 99.5. The class boundaries are basically plus or minus 0.5 of the row. So in this case, the boundary goes from 49.5 to 69.5. Another way to think about the boundaries are what's halfway between 69 and 70, 69.5. What's halfway between 89 and 90? 89.5. But again, we need to know the terminologies as well as how to calculate them. So in this case, the class boundaries for this particular row is 129.5 and 149.5. And we say the lower limit is the smallest score, is 50. The upper limit is the highest score, 149. So these are all things you're going to need to know for the problem set. Okay, here's our frequency distribution table again. How do we calculate the class width? Well, we choose any row, and we do the large endpoint minus the small endpoint plus 1. So 89 minus 70 is 19, and 1 more makes 20. So 89 minus 70 plus 1 is 20. So the class width in this case would be 20, and that's the case for all of them. How about calculating the midpoint of a row? So we would choose a row, maybe this row right here, and it's the largest endpoint minus the smallest endpoint divided by 2. And then after we do that, we add that quotient to the smallest endpoint. So in this case, 89 minus 70 is 19. 19 divided by 2 is 9.5. 70 plus 9.5 is 79.5. The other way to do it is just the average of the two endpoints. The average of 70 and 89 is 79.5. So if we look at the second row, 89 minus 70 is 19 divided by 2 equals 9.5. Add that to the 70 and we get 79.5. So the midpoint of row 2 is 79.5. How do we calculate the class boundaries? So we look at the large endpoint of row 1 and we look at the small endpoint of row 2. So 69 and 70. What's halfway between? 69.5. That would be the boundary. So the midpoint of 69 and 70 is 69.5. So 69.5 is the class boundary. It's the upper boundary for this row and the lower boundary for this row. So all the class boundaries for this particular frequency distribution table is 49.5, 69.5. Technically, we could say it again, 69.5, 89.5, 109.5, 129.5, and 149.5. The lower limit is 50 and the upper limit is 149. Okay, we're going to shift gears now. What if we were to graph our frequency distribution table? If we were to graph it and the graph has the most frequencies in the middle, and the fewest frequencies on the smallest numbers and the biggest numbers, then we say it's normally distributed or it follows the normal distribution. The normal distribution is the most common and most powerful distribution. It's symmetrical, so we could draw a line right here, and it's the same on each side. It has the shape of a bell, and it's often called a bell curve. And it can be described by its mean, which is right here. So the average of all this data would be whatever this point is right here, and the standard deviation, which we're going to learn about later in the course, but that's the average of how far a data point falls from the mean. When does the normal distribution occur in the real world? Well, the body temperatures for humans is normally distributed. So we say that the normal body temperature is 98.6 degrees, but that means 50% of all humans have slightly higher or higher, and 50% have lower. The height and weight of adults falls on a normal distribution. For men, it would be the mean would be 5 feet 10 inches or 70 inches. So 50% fall to the right of that, 50% fall to the left. The thickness and dimensions of a product. So if we say that a notebook is 2 inches thick, that means 50% of those notebooks are more than 2 inches thick, 50% are slightly less. IQ, which in standardized test scores, like the SATs, quality control test results, and errors in measurement. So let's take a look at this. We can actually use this table to predict normal distribution sizes. So if we know our sample size is 200, and this table shows the weight of dogs and their frequency. So we sampled 200 dogs, and 15 of them had a weight between 5 and 19 pounds. 28 of them had a weight between 20 and 34 pounds. 35 of them had a weight between 35 and 49 pounds. Now, if the weights of dogs are normally distributed, and they are, we can use this table to predict the rest of the occurrences. So let's go down to from 95 to 109 pounds. Well, Since the bell curve is symmetrical, how many dogs would be between 95 and 109 pounds? We would expect there to be 15 of them. How many between 80 and 94? Well, it's symmetrical, so we would expect 28. How many between 65 and 79 pounds? Well, since it's symmetrical, 35. And how many fall between 50 and 64? That would be the rest. All right, so how do we know how many the rest is? Let's add 15 plus 35 is 50, plus 28 is 78. So these three numbers add up to 78. The three below will add up to 78. So that's 156. We know 200 were sampled, so 200 minus 156 is equal to 44. So if we are correct, we should see 44 dogs have a weight between 50 and 64 pounds. So there's our 15, checking our answers. There's our 28, there's our 35, and there's our 44. How about that? It all worked. Okay. Discard. Now I'm going to go back to our course materials. Always click on course materials first. January 26th. Okay. Now, what I did not put in is that, I don't know how that didn't happen, but it should have. I'm going to add an assignment for today, and it's assignment number, problem set number 1. I always like to change the color. Okay. Problem set number 1 is going to be due on January 31st. It's worth 5 points. And if you submit it on time, get a stinky score, you can resubmit. And that's also, I'll hit submit. And now you know that problem set number 1 is due on January 31st, and it's in the folder. All right, so how do we know what problem set number 1 is? Well, we go to our course materials, and to me, that's important content. So we'll click on important content. There's the problem sets. So it's section 2, problem set number 1 right here. Look, here's the reaction time gizmo that you did on the 24th. But problem set number 1 is section 2.1 from the book. It's on frequency distribution, and it's problems numbers 5 to 13 odd. So there's the problem set. Okay, what if you do the problem set and you want to check your problems, make sure you got them right? Well, you go to the key. And here's the key to problem set number 1. Wait for it to open. Let's try that again. Ah, here it is. Okay, so you can see this shows you how you should do the problem set. So in the upper right-hand corner, you write your name, problem set 1, 2.1, 5 to 13 odd. So here's number 5. You had to construct a frequency distribution table. And it asked for the class width. So here's the calculation. The class midpoints, there they are. The class boundaries, there they are. And how many were sampled? So we added up the total number of frequencies. All right, there's problem number 7, number 9, number 11, and 13. Now, remember, folks, do not just copy this because you will get a 0 for plagiarism. All right, now I'm going to make a video on how to sign up for the course in Pearson, which is our textbook. I'm not very good with that, but suppose for whatever reason you lost internet or it wouldn't work, or what, you lost your book and you needed the pages for the problem set under an extreme circumstance. Well, you click right here and pages for problem set number 1. And it's 5 to 13. So there's 5, 6, 7, 8, 9, 10, 11, 12, and 13. All right. So from time, I will try to do that consistently unless I find people are plagiarizing by not buying the book. That's not cool. I don't want to get in trouble. So hopefully, we won't have to resort to that. Okay, so that's everything you need to know and do for January 26th. Let me stop my share. Turn on the video. I like penguins. All right. So have a great weekend, everybody. And I'll be seeing you on the 31st in person with my voice. Can't wait to see you. Take care now. Bye bye.